Can you hear me? Because I can't really hear myself. Okay, great. So my name is Radu. I work at SemaText. I do search consulting there. I'm also co-authoring Elasticsearch in Action. And my favorite use case for search engines is indexing logs. And by that I mean logs can be lots of stuff. From server logs and application logs and firewall logs and that sort of stuff to metrics or even social media data. Anything that can be sort of streamed. So yeah, I like to take logs, process them, make them into nice structured events, and index them into Elasticsearch or Solr. I've been working mostly with Elasticsearch for logs. And that helps when you want to search and analyze them in real time. And I want to ask you if you already do stuff with your logs, like centralize them or something like that. Do you? Can I get a show of hands or something? Okay, so you already do that. So I guess I'll ask you about certain technologies that I will talk about. Right, so this is also what we're trying to do with Logzine, is what Nick already said. And what's on my agenda today is to talk about three really nice log processing tools. One is Logstash, one is Apache Flume, and one is our syslog. And then because logs tend to be pretty write-heavy, I want to show you how I would tune Elasticsearch and Solr to handle lots of writes, and just a bit about scaling them out. And in the end, I will show you a demo, which is not going to be a live demo. It's going to be like a screencast that I'll walk you through, where I pick our syslog and Elasticsearch and show you like the whole path. So all of the log processing tools that I'm going to talk about, I like them because they can take logs and parse them. If you have like unstructured logs, they can parse them, and you can make out a structured document, like a JSON out of that. You can yeah, I'd say transform, but it's more about taking out data, changing stuff, and they also offer you ways to buffer your logs. So if your search engine cannot keep up with the load, or there's a spike in your logs, then buffering helps you deal with that, and then obviously deliver the logs to the search engine. So the first tool I want to talk about is Logstash, and I want to ask you if you already use Logstash or have heard of it. Okay. Right. So Logstash is a tool that is very nice for connecting stuff. Like you have lots of plugins, so you can take logs from lots of sources, whether they're files or I don't know, over the network or various data stores. You can run them to various filters, like the most popular one being Grok, which is like a wrap over regular expressions. It makes it easy for you to use regular expression to parse your unstructured logs and make them structured. And then you have lots of outputs that let you forward those logs. And if we zoom in a bit, you can have multiple inputs. If you do that, each one runs its own thread, so they don't block each other. Then you have a bunch of filter workers that do this processing that you want to do. It gets each event through all the filters that you defined. And then you have a bunch of workers that will forward the logs to your destination. And what I would like to use Logstash for is exactly that, to connect a data store to another. Like if you want, for example, to take Apache logs from a file, you can tail that file. You can process those logs, make them structures through Grok, and you can send them over to Elasticsearch or Solr. And if you need buffering, you can chain multiple logstash agents. So for example, you can have on your server a logstash agent that tails logs and puts them into something like Redis that can do the buffering for you, and then you can have a different agent that pulls data from Redis and indexes it into Elasticsearch or Solr. The next tool I want to talk about is Apache Flume. Has anyone heard of it or are using it? Okay. So it started as a way to channel your data to HDFS, and now it's more of a multi-purpose tool. The main plugins that you have are sources, which lets you get all kind of data. Channels are a way to buffer data. You can do that on disk or in memory. And then sinks are a way for you to deliver data. And you can process the data in the sense of transforming it in lots of places. The way I like to do that is in the sink. And there's one particular sink that does a very good job at processing data. I'm sure if this works as it should. And this one is called Morphline. Morphline is a library that allows you to define some commands, and then you can run your data through these commands as if they were like pipes. So if logs are coming in, then you can have a command that reads one line at a time, or can mesh multi-line logs into one event. And then you can use the grok command, which is a port of what Logstash does with grok. And you can have a load Solr command, which will load then your logs to Solr. I forgot to ask at the beginning, if you have any questions, feel free to interrupt me. And I'll be really glad to actually get some feedback and some questions. So your data flow through Flume doesn't have to be linear, like one source, one channel, one sink. You can also do stuff like fan out, so you can bind one source to multiple channels, and then from each channel you can have one sink. So this allows you to take your logs and, for example, output them to HDFS and Solr. And this is actually what I think Flume is very good at. If you need to send your logs to HDFS or Solr or both, I think this is the best tool that lets you do that. And because it also has buffering, I think it's kind of your you can do pretty much everything in one agent, although you can chain multiple agents if you want to. The last tool I want to talk about is rsyslog. Rsyslog is also modular. It has input, your logs go through input modules, message modifiers, and output modules. So you can, for example, send JSON over syslog. You can parse the JSON, append some syslog metadata like a host name or severity, and then take the bigger JSON and index it into Elasticsearch. Rsyslog also can do buffering. You can do that in a couple of places. There's a main queue and one or more action queues. And the flow of data through rsyslog comes from the input modules, where input threads put messages into the main queue. Then the main queue workers do pretty much all the work. They apply the filters and whatever configuration logic you have, and then send messages over into the action queues, and the action workers take stuff from the action queues and put them into the destination. Oh, do you have a question? Or? Oh, no, sorry. You can also have multiple such flows. So one such flow can be defined as a rule set, and you can have more of them. For example, a rule set for processing remote logs, a different rule set for processing local logs. And the nice thing about rsyslog is that it's optimized for speed, which is also what makes it light, at least on CPU. On memory, it depends on how big your queues are. And since I'm at performance, as I said, logs can be very write heavy, and it's a good idea if you can send multiple logs to be indexed in the same request. So all the tools that I've talked about can do that for you, whether you send to Elasticsearch or Solr. And when a request is sent, the logging tool typically has to wait for the indexing to be done in order to get a reply. So it makes sense to have multiple workers do this stuff in parallel if you want more indexing throughput. From this point on, it's up to optimizing the search engine to get more indexing throughput if you need that. One of the things that is pretty important is how often soft commits are done. So typically, if at a certain interval, the searchers are refreshed so that newly indexed data gets visible in searching, and this operation is pretty expensive. So you can trade off some of this freshness of the data with some indexing speed if you need to. Then there's the bit where you can have hard commits. So both Elasticsearch and Solr typically index stuff in memory, and when certain thresholds are met, the stuff that's indexed in memory gets flushed into a Lucene segment. So this operation is again quite costly. So you can change those thresholds to make them more or less rare. And once Lucene segments are written to disk, they are immutable, which means that you can generate a lot of segments. And to keep the number of segments in check, there's an operation called merging that happens asynchronously, and that can really thrash your I/O and your CPU. So you can tune your merge policy if you have very heavy writes to allow for more segments, and but this will come at the expense of search performance. Another thing that you can do is you can have time-based indices or collections. So let's say you want to keep your logs for a week. You can have one index or collection per day, which has a bunch of advantages. All your indexing will be done in the latest index, which will be smaller. There will be less segments affected, less merges going on. Most of your searching probably happens on recent data, so that should be faster as well. You can still search through multiple indexes or collections, and you can also, this design also allows you to delete entire indices, which is much faster than deleting individual documents from within an index. And both Elasticsearch and Solr offer you APIs to create, to do all this stuff, create and delete indices. And they both offer you aliases, so you can make an alias that points to one index or to multiple indices, and you can use those aliases from your application to make it easier to interact with multiple indices. Finally, if one server is not enough, you can scale out. With Elasticsearch, this is pretty easy because Elasticsearch clusters by default. You start more nodes, they form a cluster, either discovering each other through multicast or through unicast, and they elect a master, and shards typically are by default balanced across your cluster. With Solr, you have to use Zookeeper. There's an embedded Zookeeper. You can use a independent Zookeeper, and that's where your cluster information gets stored, and also where your collection settings get stored. So I've promised a demo. I will show you now. Okay. So right now, the first thing I'm doing is I'm putting a new index. I'm using time-based indices. So let's say one index for that day. And then I'm making an alias from that index, and I will call it the latest index. I'm going to show you my rsyslog configuration. The first part is about loading the modules I will use. There is one that allows me to receive logs over TCP, and there is one that allows me to send them over to Elasticsearch. Then I start the listener on port 13514. Very intuitive. And then I have a main queue, which will be in memory. This is where my logs will be buffered. And I will have two main queue workers working on it. And it will, the batch size there means that each worker will take a batch of 1,000 events and process them and then shove them over to the action queues. And this is my template. This is how the JSON that ends up in Elasticsearch is built. If you squint a bit, you will see that there's for each property there is a field name and the actual property that will get filled in there, like the time sound and the severity and specificity and so on. And finally, there's the action, where I'm referring to the template I've just defined. Whoops. Is it playing? It's playing now. Okay. So the action is going to the template I've just defined. It's going to the latest index. It's using my alias, and it's sending bulk of 5,000 messages with 5 workers. And the last line, which is resume retry count, is basically telling rsyslog to retry if Elasticsearch is not available. It retries basically indefinitely. So now I'm going to start rsyslog. Actually, the move is going to start rsyslog. And then I will go to my 1 million log file and start sending logs. So I'm just piping them over TCP or to rsyslog. This is Kibana. Have you heard of it or used it? Hey, it's a really nice tool to visualize your logs, search through them, and do all sorts of analytics. The default view will have has a search bar there, and you have the results down. And in the middle, there's the histogram that shows you how many logs appear in which time interval. It works. Okay. So I have a spike at the beginning, but I'm just going to wait for the indexing rate to stabilize. And then the plan is to apply some optimizations and see how the indexing rate will go up. So in this case, I have a really slow laptop, this one. And it's indexing at about 4,000, I think it will stabilize. No. I think at about 4,000 events per second. The screencast software is taking half of my CPU, in my defense. Right, so it stabilizes at about 4,000 messages per second. Because these are chunks of 10 seconds, so that's the average. There I have 50,000.
Is this where we're supposed to be doing an eye?
Sorry?
Is this where we're supposed to be doing an eye?
Yeah. What? Ooh, right, and you will be in awe after the optimization changes. Right, yeah. That's exact. So this is, whoa, wait. Right, so this is, the cool thing about Elasticsearch is you have lots of nice APIs, and one of them allows you to update index settings on the fly. And this is what I'm doing here. I'm increasing the refresh interval from the default 1 second to 10 seconds. I'm also increasing the threshold of how many operations to get indexed in memory until there's a flush to a Lucene index. And in the end, so the original setting was 5,000. Now I have 1 million, so that would be enough. And the merge policy I'm putting 100 segments per tier instead of the default 10 segments per tier. So this will allow for more segments. And this should help the indexing speed altogether. It works. It will take a bit. I think the plan was to explain those settings while the movie was running. Definitely. Go on. Yes, yes. So following one refresh, you will get. Sorry, what? It's going up. I'm just going to pause for a bit to answer. So the question was, what was the question again? Sorry. Oh, what does the refresh? It means that every 10 seconds, Elasticsearch will refresh the view of the index. So that means the logs that get indexed between 2 refreshes are not available for search until the next refresh comes in. Does that answer your question?
What's the default value?
What's the default value of the refresh interval? It's 1 second. There's actually a blog post on our blog where I do benchmarks with, I think, the default value and 10 seconds and 30 seconds, something like that, and show how the indexing rate varies with that. So yeah, there's a trade-off, and I guess it depends on what you need. So you can see now that the indexing rate raises to probably about 6,000 or 7,000 messages per second. So there's like a 50, 60% increase, maybe even more. Anyway, it's pretty significant. Just going to let it. Oh no. Yeah. So this basically got the whole million logs indexed right there. So I just want to show you another screencast, which is about scaling out and using aliases. This is Elasticsearch Head. It's a nice plugin, or you can just download you can clone it from GitHub and just open the web page, and you can connect to your cluster, and it will show you an overview of your nodes. So here you can see I have 3 nodes, and I have one index called logstash.1, and I have 3 shards, and each node has 1 shard. And this is the latest alias that points to this logstash index. So what I'm going to do now is I'm going to start another node, presumably because the 3 nodes cannot handle the indexing throughput. So it started here. And if you refresh, you can see it joined our cluster, but it cannot get any data because you only have 3 shards. So this is where it's nice to use time-based indices because you can you have the opportunity every day or every time interval to create a new index with a different number of shards. So now we have 4 nodes. We can create an index with 4 shards. And there it is. It gets allocated to all the nodes. And the next step is to flip the latest alias from the old index to the new one. And the operation basically consists on removing the alias that was pointing to the old index and putting up a new alias that's pointing to the new one in the same operation. So now the alias is pointing to the new index. And that's pretty much it. We're hiring worldwide if you're interested. And that's about it. If you have any questions, I'll be really happy to answer them. Thank you. You're welcome.
So once the logs come in and got all the data, are there tools to programmatically analyze something, not just visually?
So the question is, once the logs are in, if there are ways to programmatically analyze something, not just visualize tools. I'm not sure what you mean by that.
Like say you wanted to track CPU across 1,000,
Right.
and have some computation based on aggregate CPU, and then that does something else. How could you, fire that event, only when that exceeds some number?
So you mean like how we can monitor certain metrics, for example? You can do like analytics and you want to trigger something, some events.
Right.
Well, I guess you can use the APIs, the search API to do all those stuff, and then you can do that from your script or monitoring tool or whatnot to send you the alerts or do whatever actions you need. Okay.
Does the tool support semantic correlation between exceptions? So let's say an exception of type A has happened,
Okay.
another exception of type B has happened.
Yes.
And if these two are correlated, for example, let's say ABC exception has happened, and let's say S3 also timed out as a backup store.
Right.
So this basically can potentially trigger a threshold.
Right.
Let's assume one of this.
Right.
So does this support some sort of exception correlation? I said this is the thing that you basically showed us was that it captures metrics related to log analysis that you find something. But does this also support semantic correlation between elements?
I'm not sure how you can do that. Well, I guess you can search for such. I mean, how do you want to correlate? Like you want to see whether those two events happen in the same time frame or what? If you want to do that, then you can just search for. You can run a search and you can see, and the search can say, did this exception happen or did this exception happen? So both events, if they happen in that time frame, you can also specify time frame as a criteria. So if both exceptions happen in that time frame, they will both pop up.
Can we integrate HDFS and Elasticsearch?
Sorry?
Can we integrate HDFS and Elasticsearch?
Can you integrate HDFS with Elasticsearch?
Yeah.
I know there is one integration, but I didn't really use it. So I think the answer is yes, but I'm not very familiar with it. Sorry?
Do you know how we can configure some of this authentication that we have? Is there any way we can enable authentication
don't understand the question. Can you speak closer to the microphone?
Oh, okay. So we have this solution implemented in my backend. So
Okay.
Elasticsearch doesn't have any kind of authentication right now.
Doesn't have anything about what?
The authentication, like
Authentication, right, right.
So like say the same way that I have a particular document. So
Okay.
is there any way I can restrict the particular set of users to certain document?
Well, I think the common practice here is to put something, some proxy like nginx on front of Elasticsearch and hit that, and then you can do authentication, and you can also restrict users to certain URLs. I can bet there are other methods, but that's the one I'm aware of.
Out of the tools you show, Logstash, Flume, and parsing, what's the usage process of each of those? One is kind of parsing from the last one. What's usage required for Flume versus Logstash? Is it Flume or some other material?
Flume versus Logstash?
Yeah, which one to choose? Like, how to
Well,
choose which over another?
Well, what I like about Flume is that it can do pretty much everything. It has buffering, it has all those processing things. So if you need like to do everything in, like have tight integration and do everything in one place, then I guess Flume is the one to choose. Logstash, on the other hand, is very, very flexible. It has a ton of plugins, and you can write plugins very easily if you need something new. So if it's flexibility that you want, if you want to connect different stuff, I think Logstash is something that I use for that.
Logstash can also do analytics in between.
Analytics, what do you mean by analytics?
How many pages I see different.
I think this is, so the question,
Alert on exception, for example.
sorry, alert and exception. Yeah, this is something that you can do with Logstash. You can say if a message matches a certain pattern, for example, you would deliver it to a certain output, and that output could be a Nagios plugin that will send an alert through Nagios or send an email or something like that. If you want to do counts, this sort of aggregations, I think this is something that's either being worked on or it's already possible. But I think this is useful for when you have small amounts of data, I guess, or when you just want to compact, like if you're sending metrics and you want to send to Elasticsearch only the average from, let's say, 10 seconds. If you want to do aggregations, I think they're best done on the Elasticsearch side. Hi.
With Logstash, when you have been queuing by using various means,
Yes.
is there any other option there you can baked in or directly overloading?
For now, it's not built in. I'm not sure if it's intended to be built in. They have like really small queues, like 20 messages queues that different threads use to between each other. But the point is that you should use like the best tool for the job, and yeah, that's the philosophy, I think. And so you can use something different than Redis. You can use RabbitMQ or something like that.
But it's kind of outside the queuing instance.
Yes,
Like
yes.
so that's queuing
Yes.
is very
Yes, yes.
How do filters get in on here?
How do filters? How can they be configured? Well, the typical pattern is you would label every input with a tag. So, for example, if logs are coming through TCP, they have a TCP tag. If they're coming from, I don't know, a file. Sorry?
Before it will be configured, the YAML side or in the agent side?
Wait a minute, you're not talking about Logstash? Or
Yeah.
You're talking about, well, Logstash only has inputs, filters, and outputs. Flume has channels. So the typical pattern is you would have one or more sources. Like let's say you're tailing Apache logs and you're also tailing your syslogs. and you would tag them. You would say this input adds the Apache tag, and this one it adds the syslog tag. And then lower in your configuration, when you define filters, you say if the event has an Apache tag, then you would apply the grok filter with the Apache pattern, and this will do that. If you have the syslog, you will apply the syslog patterns and then forward them onto the outputs.
Wait, in which language? Is it a script?
Oh, in which language?
Script or a Java program? Or
It looks like Ruby, but I don't think it's like the full Ruby. It's just like configuration format. You say filter and then like activates. Yes. You have hashes probably. They look like hashes to me. I'm not Ruby. You're welcome. Any more questions? Okay, you can catch me later if you want. Thank you very much for coming.